Welcome to the next session of differential equation, solution of differential equation. In this session, we study the exact differential equation. So first thing is how to find the exact differential equation. We have equation m x comma y dx plus n x comma y dy equal to 0. Means m is the function of xy and n is the function of xy. So from that we call this is m and this is n. So how to find the differential equation is exact or not? For that, first we have to find partial differential of m with respect to y and partial differential of n with respect to x. If this differentiation is equal, then you call this differential equation as an exact differential equation. Now the question remains as, what is the solution of the differential equation? To find the solution of differential equation, we put integration of m dx, but in this y take as constant, plus integration of n dy equal to c, but while taking the n we take only terms of y, we neglect the term which having x. I explain you with the help of the example. Example, y 1 plus 1 by x plus cos y dx plus x plus log x minus x sin y dy equal to 0. Now this is our differential equation. Our first aim to find this equation is exact or not. So to find that, this is the m term and this is the n term. Means the term which having dx is called m term and the term which having dy is called n term. So first thing, we differentiate m with respect to y. It's a partial differentiation. Now its differential will become 1 plus 1 by x plus the differentiation of cos y, it's a minus sin y. Now differentiation, partial differentiation of n with respect to x will be the differential of 1 x is 1 plus differentiation of log x is 1 by x minus differentiation of x sin y, it's a sin y. So by looking this, we having the same value, so that we can call that del m by del y is equal to del n by del x are equal. Therefore this is exact differential equation. Now next step, to find the solution of this equation. To find the solution of this equation, our formula is integration of m dx plus integration of n dy equal to c, but we take y here constant, and while taking n term we take only y term. Means the term containing x, we neglect that term. while in n term. So integration y 1 plus 1 by x plus cos y, it's a m term, dy plus integration, here we having x, so we neglect that. Here we having x, also neglect that. Here we also having x, that neglection. So we have 0 because we don't have only y term. Remember the things, only y term we require, and while integration this we make y as a constant. So y is a constant, so y as it is. The integration of 1, it's x, plus integration of 1 by x is log x, and integration of cos y, y as a constant, so we write as cos y. Plus here 0, so that we write, here is c, 0, it's also 0. Our equation becomes y x plus log x plus cos y equal to c. This is our solution of this differential equation. We have equation y sin 2x dx minus 1 plus y square plus cos square x dy equal to 0. Our first aim to find this equation is exact or not. To find that, we find the del m by del y and del n by del x. So the term which having dx is the m term, and the term which having dy it's the n term. So this is the m term and this is the n term. So differentiate m term with respect to y, the equation becomes sin 2x, because differentiation of y will be 1, so we remain sin 2x. Del n by del x, here we have the minus sign, the differentiation of 1 is 0, differentiation of y square, because y is constant when we partially differentiate with respect to x, so y is constant, it becomes 0, and differentiation of cos square x, it becomes 2 cos x minus sin x, so that minus minus get positive, the equation becomes 2 cos x sin x, and 2 cos x sin x will be sin 2x. It's a trigonometry formula. From that we conclude that del m by del y is equal to del n by del x. So this is the exact differential equation. Now our next aim is to find the integration of this solution. Integration y sin 2x dx, here we take y as a constant while integrating, plus here we take only the y term, so minus 1, because minus sign is here, minus 1 minus y square, and it's a x term, so we neglect that, dy equal to c. Now here y is constant, so integration of sin 2x will be minus cos 2x y minus cos 2x upon 2 plus, here we integrate with respect to y, so integration will be minus y minus y cube by 3 plus equal to c. So our final equation becomes minus y cos 2x by 2 minus y cube by 3 equal to c. We take minus sign on that side. So our final answer will be y cos 2x upon 2 plus y cubed by 3 equal to c. So this is the final solution. We take c as any value because c is the constant.